So this section, we're going to work on adding and subtracting rational expressions. So our goal when you have rational expressions, so let's say we've got P over Q, and we're adding that to a second rational expression, which would be R over Q. And so you bring over that common denominator of Q, and you add the numerators. Not so bad. Now, the only thing we need to be concerned with is Q cannot be equal to 0. That's fine. If you have a subtraction, okay? So the only thing that's different about this is our subtraction sign. So that would be P minus R, or P over Q minus R over Q. Bring over that common denominator of Q, and it'd be P minus R. Again, our denominator cannot be equal to 0. So the key here is we just need that common denominator. So if we are going ahead and we have common denominators, thing I notice about this example is it's a subtraction. And so what we're going to want to do is we're going to want to put parentheses around that second numerator. You can just out of habit put them around the first one too, just so you get used to it. But we want to make sure that with that second binomial that we don't mess up our signs. And that would be the purpose of the parentheses. So remember to distribute that subtraction sign. So then that when we distribute, it's going to flip the signs. So we're going to have x minus 3 minus 6x plus 17. Combine our like terms to get a negative 5 plus 20. Take out that negative 5, which is a common factor, a greatest common factor. And then we have in the numerator 5 times x minus 4, and then the denominator x minus 4. Those reduce, and we're just left with negative 5. Okay, so let's apply this idea or this concept to these different examples. So I see that I have a common denominator. So all I need to do is bring over that common denominator and add 22 plus 7 to get 29. I can look to see if I can reduce, but I cannot in this case. So that is my answer. All right, let's go ahead. We've got b minus 5. So we bring over the b minus 5. So it's not b minus 5 squared, or it's not 2b minus 10, nothing like that. It's just plain old b minus 5. Now for our numerator, it's going to be 17 minus 11, which is going to give us 6. That one is done. Let's go ahead and look at this third example. Again, the denominators are the same, so we bring them over. Then I'm going to take 8y squared minus 8y. Okay, so I can have a little fun with this one. I'm going to take my numerator, and I've got a greatest common factor of 8y. When I pull that out, I'm left with y minus 1. And I still have a y minus 1 in the denominator. So I'm going to go ahead and I am going to reduce the y minus 1s. And so then I am simply left with, I'm left with 8y. All right, let's look at number 4. Our denominators are the same. So I'm going to bring over that common denominator of x minus 2. My numerator is x squared minus 5x plus 6. So what we notice here is we have a trinomial, and it's a quadratic. We can factor that. So I'm going to take and factor that and get x minus 2, x minus 3. And in the denominator, I have x minus 2. These x minus 2's reduce to 1, and so then I'm simply left with x minus 3. You should be feeling really good right now. This is very straightforward. Nothing too fancy about it. The key is, once we have the common denominators, everything just flows. Unfortunately, all of our rational expressions, when we want to add and subtract them, don't have common denominators. So we need a couple skills to help us so that we can kind of manipulate our rational expressions in order to create common denominators. So the two skills that we need are, one, we need to be able to find a least common denominator, and then we need to be able to find rational expressions. Okay, so let's look at these one at a time. Let's first work on finding a least common denominator. So when we're looking for an LCD, the first thing we're going to do is we are going to factor all the denominators completely, okay? The least common denominator is going to be the product of unique prime factors from those denominators, where each factor is raised to the highest power to which it appears in any denominator. Wow, that's a lot. What does all that mean? All right, well, let's just take a peek at it. All right, let's look at just fractions that have just regular numbers to them before we look at rational expressions. So 1/12, 1/6, and 1/18. We're going to first take the 12. And when we break it down into its prime factors, that leaves us with 2 times 2 times 3. How did we get that? That was just taking that 12 and breaking it down using a factor tree, okay? And so that 2 times 2 gives us the 2 squared. So 2 squared times 3. Now let's do the same thing with the 6. We break it down into its prime factors. It's 2 times 3. And then with 18, it's 2 times 3 times 3, or 2 times 3 squared. Now here's where the tricky part comes in. So when we compare, let's start with comparing the 2's, okay? So I'm looking at 2's, and I've got a 2, a 2, and a 2. I'm going to pick the base 2 that has the highest exponent. That's what I'm going to use for my least common denominator. This was the opposite of what we did when we were looking for a greatest common factor. So confusing. But when we're looking for a least common denominator, we want the highest exponent. Now when I look at my 3's, it's my 3 squared that is going to be my highest exponent. So that becomes 4 times 9, so my LCD is 36. All right, the same process works when we have polynomials. We first need to factor them. So when we factor x squared plus 2x plus 1, that's when we get x plus 1, because it's a perfect square trinomial, okay? And that is x plus 1 squared. Then if I take my x squared plus x and take out a greatest common factor of x, I've got x times x plus 1. Those are each separate factors, the x and the x plus 1. So when I'm looking and comparing x plus 1 from each of those denominators, I'm going to pick the x plus 1 that has the highest exponent. That's what becomes part of my LCD. And then I still have that x plus 1, which is unique, so I need to bring that down there. So that whole thing is going to be my LCD. Oof. So all we're going to do right now with these next 4 problems is work on finding a least common denominator. That's a skill that we must be very good at. So first thing we want to do, factor the denominators. So let's go ahead and do that with this first problem 5. So I know that 10, in order to get 10, I can do 2 times 5, and that also adds to 7. So this is going to be x plus 2, x plus 5. Now for my second denominator, I'm going to do the same thing. That looks like it could be a perfect square trinomial, which would be x plus 2 squared. And sure enough, if I check it, it would be 2 times x times 2, which gets me back to that 4x. So that just proves that, yes, that is a perfect square trinomial. So I factored it correctly. But now the important thing, my LCD. So I look at my x plus 2 and my x plus 2. I'm going to pick the x plus 2 that has the higher exponent. So x plus 2 squared. But then I also need to pick this x plus 5. I can't leave it out. I get to be a little greedy. All right, let's go over to problem 6. So for this one, I'm going to start by looking at my numbers, 6, 12, and 9. So 6 is the same as 2 times 3. 12 is the same as, well, let's just do 3 times 4 and then 2 times 2, okay? And then 9 is the same as 3 times 3. So when I look at my 2s, so to find my LCD, I'm looking for my highest exponent. So when I look at my base 2, well, I've got 2 of them with that middle expression, so 2 squared. Then I look at my 3s, my base 3. Well, this 9 gives me 3 squared. Then I've got my x's. Let's go look at my variables. I've got x cubed, x squared, x to the first. Well, I'm going to take x cubed. When I look at my y's, my y cubed is the largest. And then I look at my z's, z to the fourth. The only thing I need to do is I need to take those exponents that have integers as a base, and I need to go ahead and multiply them out. So that's going to be 4 times 9, or 36. So my LCD is 36, x cubed, y cubed, z to the fourth. Okay, let's do the next one. So for this one, I've got x minus 2, and I can't do anything with that. But this x minus 2, x squared minus 4, is x minus 2, x plus 2. All right, so my LCD, I've got an x minus 2 in the first rational expression and an x minus 2 in the second one. And so I'm just going to use x minus 2 to the first. Then I also need that x plus 2 because I have to pick up every unique or every different factor that is in the denominators. So that's why I scoop that one up. I leave them in factored form though, because it's going to make it easier when I'm trying to find common denominators. Let's go ahead and do this last one. So this one, I've got a perfect square trinomial. It's x plus 3 squared. Then I've got with this next one, it's going to be x minus 4, x plus 3. So my LCD is going to be x plus 3 squared times x minus 4. Okay, let's move on. Now we're going to find equivalent rational expressions. So we start, what that is like is, remember with fractions, if I had a fraction, let's say just a plain old example here, if I had a fraction that was 1/2, okay, and I wanted to create an equivalent fraction that had a 6 in the denominator, okay? Well, what I would need to do is I would need to figure out what do I need to multiply that 2 by in order to get to 6. Or another way of thinking of it is 6 is the same as 2 times 3. So when I compare the 2 to the 2 and the 3 is missing. So I'm going to multiply this first fraction by 3/3. And that is going to give me 1 times 3, which is 3, over 2 times 3, which is 6. That's the process that we're going to use to create equivalent rational expressions. Same process. All right. So, actually, I think the explanation, you can go through that example. Let's just go right here to like 9a. Okay. So the first thing we want to do is we want to take that denominator and we want to factor it. So when I factor that, I get x minus 2, x plus 1. And so when I compare the x plus 1 to the to my goal, my intended denominator, I see that my x minus 2 is missing. So that just means I need to multiply this first rational expression by x minus 2. That's how I create my equivalent rational expression. So this is going to give me 5x times x minus 2. I'm going to go one step further, and I'm going to distribute that 5x. So I'm going to get 5x squared minus 10x over x minus 2, x plus 1. There we go. All right, let's do the next one. So I'm going to factor. So when I factor, it's going to give me x minus 5, x plus 3. So I can see what's missing from that first denominator, okay, is this x plus 3. So I am going to multiply by x plus 3 over x plus 3. So as I multiply those, that's going to give me x squared, okay, minus x plus 3x minus 3. I can combine my like terms here to give me a 2x. So it's x squared plus 2x minus 3 in the numerator. I guess I could kind of clean that up a little bit. X squared plus 2x minus 3 over the x minus 5, x plus 3. So let's pause here. What did I just do again? Oh yeah, what I did is I started with this original rational expression and I found an equivalent. rational expression. That's what we're doing. Okay, let's go ahead and look at C. So the first thing that we want to do is we want to factor the denominator. And so that's going to give me x minus 1, x plus 7. Then I compare my two denominators and I multiply top and bottom, numerator and denominator, by missing factor. All right, so when I compare these two denominators, I see that it's the x plus 7 that's missing. That's what I'm going to multiply by. X plus 7 over x plus 7. The reason why I do both the top and the bottom is because that's equal to 1. So it's like I'm multiplying that first rational expression by 1. So I'm keeping the integrity of my problem. That's how I'm keeping equality. All right, so now as I multiply, I'm going to get x squared plus 7x in the numerator and x minus 1, x plus 7 in the denominator. All right, let's do D. So D, after all of this factoring, D doesn't have any factoring. All I'm going to multiply by are the missing factors. I still need to find my LCD. So my LCD is going to be x squared, y cubed, z to the 5th. So when I compare my first denominator with my LCD, I can see what's missing. Okay, so I see that I need one more x. So I'm going to multiply by an x. I'm good with the y's, but I need 3 more z's. So I multiply both the top and the bottom by xz cubed. Okay, so that's going to give me 6xz cubed over the x squared y cubed z to the 5th. All right, now let's put it all together. So now our goal, remember, is to be able to have common denominators so that we can just, once we've got the common denominators, we just add and subtract the numerators. That's where we started, and that was not so bad. But we have to get there. So what do we do when we have unlike denominators? Well, we first start by factoring the denominator of each rational expression. Then we identify the LCD. Our third step is to rewrite each rational expression as an equivalent expression with the LCD as the denominator. Fourth, add or subtract the numerators, and then you simplify it if you need to. Whew, that's a lot. All right, let's do it. So we've got this crazy example here. All right, so we'll go through that kind of quickly. We start with 2 rational expressions, and they are being subtracted. So our very first thing is we need to factor those 2 denominators, which we've got. From those 2 denominators, we can find our LCD. So we've got 1, y minus 1, because our highest exponent with the y minus 1 is 1. And then we have a y minus 2 right there. So we got a y minus 1, a y minus 2, and we have a y plus 1. So those are all of our unique factors, or I should say all of our different factors, all brought together. All right, so now when I compare my very first rational expression, I look at it and I ask myself, when I compare it to my LCD, what is missing? Well, it would be the y plus 1. So that's why that first rational expression is multiplied by y plus 1. I do the same process with my second rational expression, and I see that that one is missing the y minus 2. So now both of those rational expressions have the same denominator, and it just happens to be the same as the LCD. All right, so now I can take and subtract my numerators. So that's what we're doing right here in this step. We need to be careful. We put parentheses around, we actually distributed that 6, and then put parentheses around the 6y minus 12 so that we don't make an error when we distribute that subtraction sign. So now in the next step, I've got 4y plus 4, and then minus 6y plus 12. I just combine my like terms, and I end up with negative 2y plus 16. When you factor out the negative 2, this is what you end up with. If you could reduce at that point, you would, but we can't. All right, let's go ahead and try number 10. Why not? So we've got the only thing that can be factored is this middle expression, and that's going to be x plus 2, x minus 2, because that's the difference of two squares. My LCD is going to be x plus 2, x minus 2. So I'm going to set this up, okay, like this. And I am going to rewrite my first rational expression, 8, and then x minus 2. I'm going to multiply that first rational expression. I'm going to look at my LCD. I see that the denominator is missing an x plus 2. So I'm going to multiply both the top and the bottom by that missing factor. Now I'm going to go to my middle rational expression. That one is not missing anything. I've got it all. So I don't have to multiply by anything to create an equivalent rational expression. My last one, or the third one, is missing the x minus 2. So I'm going to go ahead and multiply both my numerator and my denominator by that x minus 2. Now I have a beautiful thing. All three of my denominators are the same. So what I'm going to do at this point, I'm going to draw a fraction bar. I'm going to put my common denominator in the bottom, okay? I'm going to take and I am going to multiply or distribute and then bring that down into my numerator. So 8x plus 16 plus, I've got my middle x minus 6, and then I'm going to distribute the 2 and get plus 2x minus 4. So now at this point, it's pretty easy for me to go ahead and combine my like terms. So 8 plus 1, because there is a 1, it's an implied 1 in front of that x. 8 plus 1 is 9, plus 2 is 11x. Now I'm going to take 16 minus 6 is 10, minus 4 is 6. So 11x plus 6, and then I've got that over x minus 2, x plus 2. All right, let's go ahead and do another one. Okay, we've got, we'll see. Let's try 11 for sure. So for problem number 11, we first want to factor that denominator. So when we do that, we're going to get b, b minus 5, b minus 2, and then for the second one, it's going to be b plus 8, b minus 5. All right, so we can write our LCD. Our LCD is going to be, we'll start over to the left, b minus 5. Our highest exponent on either one of those is 1. So we just take 1. Then I've got the b minus 2, and then the b plus 8. All right, so let's go ahead, rewrite this first rational expression. So that's going to be b minus 3, and then I've got the b minus 5 and the b minus 2. When I compare that denominator to my LCD, I see that the b plus 8 is missing. So I'm going to multiply both the top and the bottom by b plus 8. Now I'm going to go to my second rational expression. I have 2b plus 7. Then in the denominator, I have b plus 8, b minus 5, and I need to see what is missing. Well, it's the b minus 2. Okay, so now I can put everything under the same rational expression because now I have common denominators. My common denominator matches my LCD. So b minus 5, b minus 2, and b plus 8. Okay? All right, so for my numerator, I need to multiply over here on the left. When I multiply those out, I get b squared plus 5b minus 24. Now I've got my addition sign I bring over, and now I'm going to multiply my second two binomials. And when I multiply those two out, I get 2b squared plus 3b minus 14. All right, so now I can combine like terms. So I've got a b squared and a 2b squared to give me 3b squared. And then I have a 5b and a 3b to give me 8b, and minus 24 and a minus 14 gives me a minus 38. All of that over b minus 5, b minus 2, b plus 8. I can tell you, because I've already worked on this problem, that numerator cannot be factored anymore. So we're done. If it could, you would need to sit there and see if you could factor it a little bit more though. Okay, let's try number 12. Yeah, we'll do 12. Okay, so for number 12, we're going to start with our common or actually are factoring our denominators. So that is going to be x minus 3, x minus 2. And then for the second one, it'll be x minus 2, x minus 4. So our LCD for this one is going to be x minus 3, x minus 2, x minus 4. Okay? All right, so for this first rational expression, what's missing is the x minus 4. So I'm just going to take a shortcut here. I'm going to write x minus 4, x minus 4. And then for that second rational expression, it's missing x minus 3. X minus 3, x minus 3. Okay, so now we can put everything under the same common denominator. Okay, so let's go ahead and distribute. So that's going to give us 4x squared minus 16x, but then we've got this minus sign here, and we need to be careful. I'm going to first distribute, so that's going to give me 16x minus 48. When I remove those parentheses, that will change the signs of each of those terms in that inside of the parentheses. So when I remove them, it becomes a minus 16x plus 48, like that. All right, so now I can go ahead and bring this together. So this is 4x squared minus 32x plus 48 over this common denominator. You would think, gosh, we must be done, right? No. One of the things that we notice about this numerator is that all of those terms can be divisible by 4. So that means I have a greatest common factor of 4 that I need to pull out. And so that's going to give me x squared minus 8x plus 12. All of that over this common denominator. So now I need to see, can I factor that trinomial? And I can. 6 and 2. So this is going to be, let's go ahead. It'll be 4 times x minus 6, x minus 2. So that trinomial can factor down to x minus 6, x minus 2. In the denominator, I still have x minus 3, x minus 2, x minus 4. Right now, what I need to do is I need to look to see if I can reduce, and I can. The x minus 2's get reduced, and so then my final answer is going to be 4x minus 24, so I just distributed that 4, over x minus 3, x minus 4. That is my final answer. Crazy. That's a big one. All right, so for number 13 and number 14, do I have my answers? I've got an answer for number 14 here in case you wanted to give it a try, but I'm going to actually, I'm not going to do 13. I want to look at one that actually I'm going to do 2 that I think you're going to run into in the homework. So x plus 2 over x minus y minus 2 over y. Seems like a simple problem. So the first thing we want to do is find our LCD. Our LCD is XY. So we take that first expression, multiply it by y over y. We take the second expression and we multiply it by x over x. So now we're going to have a common denominator of xy. We need to put parentheses and distribute that y. So we're going to have xy plus 2y. Now I'm going to do the same thing with the second set. This is an x there. So it's going to multiply in parentheses. I'm going to have xy and then minus 2x. The reason why I put those in parentheses is because I don't want to mess up that negative. So when I remove the parentheses on top, I'm going to have xy plus 2y. Now, minus xy plus 2x. Oh my word, that is craziness. All of that is over xy. So, this xy and this xy are additive inverses. So they become 0. So this whole thing becomes 2y plus 2x over xy. That's your answer. It's crazy. All right. The answer for number 14, should you want to give it a try, is negative 9x minus 44 over, oh, could I just understand my writing? Yes, 5x minus 4 and x plus 4. All right, so you have enough information here, enough examples in order to be successful in your homework. So try your homework and have fun with it.